Number 11. Solve for x round to the nearest tenth. We're given a side, an angle, and we're trying to find the other side. Well, whenever we see an angle given, we know we're going to have to use trigonometry or SOHCAHTOA. These are the ratios we're going to use. First one is sine, opposite over hypotenuse, cosine, adjacent over hypotenuse, and tangent, opposite over adjacent. So the first step, circle the angle we're given. Label the sides with opposite, adjacent, or hypotenuse. I always label the hypotenuse first. And then the x is on the other side, so that's going to be O. So we've got O and H, we're going to use the sine. Now we'll write out our equation. Sine, then the angle measure, which is 25, equals opposite, which is x, over hypotenuse, which is 30. At this point, all we have to do is solve for x. I multiply both sides by 30. That will leave me with x on the right side. Going to my calculator. We want to make sure that it's in degree mode, so we're going to press the mode button. I am in degree mode, so I'm good. I can clear that and just type in 30 sine 25. It gives me 12.67 to the nearest tenth would be 12.7, so x equals 12.7. All there is to it. Number 12. Solve for x round to the nearest degree. Okay, again, we circle the angle, label the hypotenuse, and now this one is the adjacent. So adjacent hypotenuse, we're going to use cosine. So cosine of x equals adjacent 8 over hypotenuse, which is 16. Whenever we don't know the angle, we just have to do an extra step. We're going to hit the second button first, then cosine, and then 8 divided by 16. And that's going to equal x. Go to our calculator. Second button is right there. Cosine, 8 divided by 16 equals 60. So x equals 60. Now you might see one other type of problem on your exam, and I wanted to show you that one, so we'll call this 12B. Have a right triangle here. This time your angle measure is up here. You're looking for this leg, here's your right angle, and we know that this one over here is 12. Let's make this x. We're looking for x here. Okay, so here's our angle measure. We've got opposite, we've got adjacent. We're going to use tangent. So tangent 40 equals 12 over x. So third type of problem, this time you have x on the bottom. In this case, you're just going to switch these two. Put x on the left equals 12 divided by tan 40. Just type that in your calculator. 12 divided by tan 40 equals 14.3. So x equals 14.3. And that is our answer. Number 13. Which graph shows the original figures in image under the given translation? They give us the vertices, and then they say the translation is left 2 units and down 3 units. So what we need to do is see which one of these translates it in that manner. So first of all, we need to identify the new one. The new one is the one with the tick marks. That's one on the left. So we're going from this one to this one. So let's see, if we go down left 2 units, 1, 2, and then down 3, 1, 2, 3. That does not put us on F prime, so that's not the right answer. Let's check B. E is right here. We're going to go left 2 units, 1, 2, and then down 3, 1, 2, 3. E puts it on E prime. Since they're in the same orientation, we're just going to say that B is our answer. That's number 13. Number 14, we want to determine the scale factor of A, B, C, D to A prime, B prime, C prime, D prime. Now what you need to remember is that when you're saying scale factor of something to something else, the first one is always going on top. So we're going to set up our ratio A, B, C, D to A prime, B prime, C prime, and D prime. You can pick any side since they're the same shape. Let's just take this one right here. A to B is 4, and A prime, B prime is 2. So we'll reduce that to 2, and our answer is A. Just like that. Number 15 says determine the number of lines of symmetry for the object below. Lines of symmetry are also known as fold lines, where we can fold an object over onto itself. So we want to see where we can draw lines through here where we can fold it onto itself. Well, I know we can fold it right down the middle here. That'll fold over. We can go through these two sides, and we can go through these two sides here. So we've got 3 so far. I also see that we could go through these points here, and these points here. So we got 3 through the sides and 3 through the points. So the number of lines of symmetry is 6. Number 16, if point A is reflected across the y-axis, what is A prime? Okay, well they give us the coordinates of A here, and we're told it reflected over the y-axis. Now we've got a rule for that. Anytime you reflect a number across the y-axis, the x-coordinate changes its sign. So the A prime would be positive 4, positive 6, and that would be B. If you forget that, you can draw yourself a little graph here. Plot A at negative 4, positive 6. Know that we're rotating it or reflecting it over there. So the x-coordinate has to be positive, so this is going to be positive 4, positive 6. That's the other way you could do that problem. That's number 16. Number 17, the figure is apparently symmetric with respect to both the x and y axis, neither the x and y axis, the x axis only, or the y axis only. Well, we can look at this and see that we cannot fold this over the x axis and have it match up exactly. The only way we could do that is over the y axis, so our answer is D. 17, what type of transformation is shown below? Well, if you look real closely, you'll see that the one in the back is bigger than the one in the front, so it must have been flipped. So a flip is also known as reflection. Number 18. Write an equation for the circle whose center is negative 1/8 and whose radius is 10. Okay, equation of a circle. The center of the circle is going to be HK, and the equation is going to be x minus h squared plus y minus k squared, which equals the radius squared. That's based on the distance formula, but we don't need to remember all that at this time. All we need to know is that we're going to subtract the x-coordinate from the x here, y-coordinate from this one here, and plug the radius in here. So underneath here we'll just do x minus negative 1 squared plus y minus 8 squared equals the radius, which is 10 squared. Now that we've written it, all we have to do is simplify and we're done. We can make that positive, so we'll make this x plus 1 squared plus y minus 8 squared equals 100. And that's that. Now for the next problem, I think the easiest way to do this one is by graphing it, because we need to find the center and the radius. So you're going to have some graph paper. I'm going to move this up a little bit so you can see the graph too. And I'm just going to draw a set of axes here. Not terribly straight. And it needs to go to 8, so let's just do that. Okay. So the diameter has endpoints -4, -6, 1, 2, 3, 4, 5, 6, right there. That's -4, -6, and 8, -6, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6. This is 8, -6. Okay, now we need to find the center and the radius. So if this is the diameter. We know it's going from -4 to 0 is 4 spaces, and then 8 more is 12, so we're going to go up 6. So our center is going to be right here. The center would be at +2, -6. The radius is going to be from the center to the outside of the circle, so that's going to be 6. So now going back here, we can write the center as 2, -6, and the radius as 6, and plug that into our formula. So it'll be x minus the x-coordinate, which is 2, squared, plus y minus the y-coordinate, -6, that squared, equals the radius, which is 6 squared. Simplifying, x minus 2 squared plus y plus 6 squared equals 36. And that is the equation of that circle.